Hi everyone. As we said in the previous video, we will not be guessing what is the function whose derivative is 2x. We need rules of integration, and those rules are very easy because all of them are related to the differential theorems or the rules to find the derivatives of the function. So let's start. Here we have the first set of rules of integration. So here we have the integral of a constant times f prime of x differential of x. When we have a constant multiplying the derivative of a function, all we have to do to find the integral is to multiply the constant times the resulting integral of f prime of x times dx. So if you remember the rule for the derivative, we used to say that the derivative of a constant equals, the derivative of a constant times a function equals the constant times the derivative of a function. So we have the same rule. Second rule works for addition and subtraction of functions. We have addition and subtraction of f prime and g prime of x. So times differential of x. So all we have to do when we have an addition or subtraction of a function is just to obtain the integral of f prime of x times dx plus or minus the integral of g prime of x times dx. So for those two rules, we don't need to think much. As you can see, constant times the integral of f prime of x equals constant times the integral of the function. So the integral of an addition of or subtraction of function equals the addition or subtraction of integrals. Now we have the integral of 1 times dx. The integral of 1 times dx equals x plus the constant, because the derivative of x with respect to x equals 1. So now we're doing the opposite. Now we're going to spend a few minutes explaining this one, okay? This is the integral of x to the n times dx. If you remember, when we last semester to find the derivative of x to the n, and I'm going to write it here, if we had the function f of x equals x to the n, its derivative was f prime of x equals n, that means multiplying by the exponent times x to the n minus 1. My God, I don't have a space. But you remember this rule, right? So now we have the opposite. Now we have the integral of x to the n times differential of x. So the integral of x to the n times differential of x equals x to the n plus 1, because for the derivative we subtract 1 to the exponent. And we're going to divide by n plus 1 instead of multiplying, because we're doing the opposite operation. So the integral of x to the n times dx equals x to the n plus 1 over n plus 1, which was the primitive or the original exponent of the function. But we have to point out that n must be different from -1, because when n equals -1, we would have an indefinition in that denominator. That would be -1 plus 1. So we need another rule for this case. And that rule is this one here. So the exception for this rule, which is n equals -1, will be the integral of 1 over x times dx, because let me move a little bit this up here because I need some space to remember the following. Remember that x to the negative 1 can be written as 1 over x. So that's why I'm saying this is the exception of this rule when n equals -1. So the integral of 1 over x times dx equals the natural logarithm of x plus c, which is the exception of this. Well, now, of the three rules that you look here are the generalizations of these three. So this is with respect to x, differential of x, differential of x, differential of x. And we have here differential of u, differential of u, and differential of u. Remember from last semester that we used u as a function of x. So now, if you have 1 times the differential of u, the integral will be u plus c. If you have the integral of u to the n times the differential of this function of x, then the integral will be u to the n plus 1 over n plus 1 plus the constant. And the exception for this rule, if you have a function to the negative 1, that will be written as 1 over u. So the integral of 1 over u times differential of u equals natural logarithm of u plus c. Okay, before I solve some examples, I would like you to look at this image. It says the derivative of the chicken with respect to x equals the egg. Now the integral of the egg equals the chicken. Is that clear? So we're doing the opposite operation. I'm going to adjust a little thing here because here we're missing the dx. Okay, now this image is perfect. Let's start with the examples. Well, one more thing. There are no rules for the integral of quotients, neither rules for the integral of products. So we're going to use only the 5 rules we already know, and do not try to integrate quotients as if it were additions, neither products, okay? Keep that in mind. Well, let's think of the derivative of y with respect to x, which equals x squared minus 2x plus 5. Okay, this is the derivative. So we're going to solve for the y. So the right notation will be differential of y equals equals x squared plus 2x plus 5 times dx. And then we use the symbol that means finding the function whose derivative is x squared minus 2x plus 5 times dx. So this expression comes from the derivative. Okay, so we have here the integral of x squared minus 2x plus 5 times dx. What rules are we going to use? Remember that we have the rules to help us solve this. So the first thing that I want you to see is that we have a subtraction and an addition. So since we have a rule for that, we want to use it. So we want to do the integral of x squared times dx as a function minus the integral of 2x times dx plus the integral of 5 times dx. Then for this term and this term, we have a constant. We have a constant here, 2, and we have a constant here, 5. So we're going to use the first rule that says that the integral of a constant times a function equals the constant times the integral of the function. Same thing here. Constant times the integral of the function. The function is 1 because the constant is 5. Then here we're going to use the rule that says that the integral of x to the n times dx equals x to the n plus 1, so now will be x cubed, over n plus 1, which is 3, plus a constant, minus the constant times the integral of x to the 1. Remember that we have an exponent here that is not written, but it's 1. So we're going to add 1 to that exponent. We want to obtain 2, and we're going to divide by 2, plus the constant, plus 5 times the integral of x. Remember, the integral of 1 times the x is x plus the constant. And we obtain x cubed over 3 plus a constant minus x squared, because we simplify 2 over 2 equals 1 times x squared equals x squared, plus 2c, because we're multiplying 2 by c, which is negative, but it doesn't matter, you're going to see why. And then we have 5 times x here, and 5 times the constant. But we have too many constants, and we don't know exactly what are the value for those constants. So we're going to get rid of those many constants, and we're going to write that c plus 2c plus 5c as just one constant. So look at this. So as I was saying, do we know the value of the constant? And we have so many constants here. So we have c plus 2c plus 5c, and we're going to write it as a single arbitrary constant. So we're going to have x cubed over 3 minus x squared plus 5x plus just one constant. So this is the original function, the antiderivative or the indefinite integral. How can we check the final result? Pretty easy, just by obtaining the derivative of the function, or by differentiating the answers. So if you want to make sure that you did it right with this integral, all you have to do is to obtain the derivative of it.